Welcome. In this video, we're going to be looking at modeling with rates, ratios, and proportions. So to start off here, we just have a little vocabulary, and that is talking about a unit rate. A unit rate is something that you probably use a lot without even really realizing it. And a unit rate is just anything per one. So we use this when we have things like miles per hour. That's how many miles you can go per 1 hour. Or if you're looking at the cost of something, usually it gives a like per each. Well, that's like per one. So unit rate, we always want our rate, the denominator of our rate, to be one in a unit rate. So if we're trying to find the unit rate of $235 for 4 shirts, I want to know how much does it cost for one shirt. So to do that, we can just do 235 divided by 4 will give us our unit rate for one. So if you need to, go ahead and get out a calculator and use that to do 235 divided by 4, and then it'll give you your unit rate per one is 58.75. So our unit rate is 58.75 per shirt. So we know how much it costs per one shirt rather than for 4 shirts. Okay, so that's going to be important in what we're looking at today, as well as being able to communicate between the difference between percent, decimal, and fraction, because they are all related. Percent is always out of 100, so that can help us with our decimal and our fraction here. So if we're looking at our fraction, we can just take that 56%, means I got a 56 out of 100. Okay, that 56 out of 100, that is an equivalent fraction. However, usually we want our fractions to be simplified. So we can do that 2 ways. One, you can look for a common factor here and simplify your fraction by dividing out a common factor. That is a great skill to have and use. I'm going to show you with the next one how you can get there if that's a little struggle for you. So if we divide these by 2 to get started, right, they're both even. 56 divided by 2 is 25, 6, 7, 8, 28 over 50. Oh, those are still divisible by 2. So when you divide by 2 divided by 2, we get 14 over 25. Those have no common factors, so that is our simplified fraction there. Okay, to get our decimal, we're also going to be looking at that it's hundredths. This is 56 out of 100, so it's 56 hundredths if we read this fraction, right? That's what this means. So our decimal is just in our hundredths place, which is the second place over. It's 56 hundredths. It's 2 decimal places over. If you're not sure about that, you can also do 56 divided by 100. And you get 56 hundredths, the same thing. Okay. If we are looking at 8%, okay, do our decimal first, that is 8 hundredths. So tenths, hundredths, it's 8 hundredths, which means we need a 0 placeholder here to say stay in that hundredths place. Okay, it means it is 8 out of 100, which is our fraction, but again, that is not a simplified fraction. So we can utilize our simplifying, and I'll show you how to do that on your calculator here too. But 8 and 100 both have a common factor of 4. If you didn't see that, you could start with 2. And we get 2 out of 25, which is a great place to go. If this is a struggle for you, hang on one second. Sorry about that. Wanted to get a calculator that matches your calculator. I forgot to grab it first. So if you are utilizing the 30, this is what you can do on here if that fraction is a struggle for you. Knowing this is going to be very helpful for other skills we're going to do down the road. But if that's a hurdle for you right now, how we can do that is keeping in mind that fraction is division. So you can actually do 8 divided by 100, and it will give you the decimal. Oh, that matches here. Okay. And then to change it into a fraction, if you hit second and then this PRB button here, that changes fractions to decimals and vice versa, and hit enter, it will give you the simplified version of that fraction. Okay. So utilize that as a tool as needed. Again, being able to think through this process, know your factors is going to be very helpful with other skills we're going to do down the line. So please don't give up on that. However, if you need to utilize your tools to help you get there, that is fine too. So let's try a couple more. Ooh, 0.5%. That's a half of a percent. So really what this means, I don't have any hundredths. I'm way over here. That's 5 thousandths. So our fraction here is 5 thousandths. Both of these are divisible by 5. So if we divide by 5, divide by 5, we're going to get 1 out of 200. If you're not sure, use your calculator to check. Did I do that right? 1 divided by 200, it should be equal to 0.005 or 5 thousandths. Looks like we got to the right place. Hey, oh, this one's different. It's 180%. It's more than 100, which means we have 100%, which is 1, and 80%. So we could write it 1.80 or 1.8 is totally fine too. So that means we have 180 out of 100. Okay, oh, n and 0, they're both divisible by 10. 18 out of 10, both even, divisible by 2. 9 out of 5. If you try to do this one on your calculator, it's a little bit more challenging because it's an improper fraction. So if I did 180 divided by 100 on my calculator and did that second PRB, oops, it will give me this weird looking thing. I don't want that weird looking thing. That's a mixed number. I'd rather have an improper fraction. So to get there on your calculator, you can hit second again and then the button below PRB, and it will give you that improper fraction here. So that is our fractions, decimals, percents. Get used to those, get good at them, because when we use percents, we rarely actually use the percent. Usually we use the fraction or decimal version. So if I want 30% of 80, I need to find what is 30% as a decimal times 80. If I take 0.3 times 80, I'm going to get 30% of 80. 24 is 30% of 80. If you're not sure, go back to your fraction. 24 out of 80 should be equal to 30%, which it is. Okay. What percent of 45 is 35? This is where using that translating your sentence. We don't know the percent of 45, but we know it is 35. What percent, that's the thing I don't know, 45 is 35. So to find this percent, we're just going to divide both sides by 45 here. And get that our percent is 35 divided by 45. This thing. Okay. So we got 0.77 repeating, which is, if we change that into a percent, 77.7 repeating percent, which is also 77 7/9%. All right, if it repeats or ends, it is rational. We should be able to write that as a fraction as well. Okay, let's look at a couple more examples here. 230 is what percent of 200? So 230 is what percent of 200? Looks very similar. Okay, 230 is more than 200. Take a second to think about that. That means that the percent has to be more than 100%, right? 230 is more than 200. It's more than 100% of 200. So we should end up with something over 1. So if we divide by 200, 230 divided by 200, we get 1.15, which means that it is 115% of 200. So if I took 200 and I multiplied it 115%, 1.15 as a decimal, I should get 230. Perfect. 38% of what number is 85? So this one's a little different. This is the thing we don't know. 38% as a decimal of what number is 85? Okay, think a second. Should it be bigger or smaller than 85? Taking 38% of something, we're getting 85. So what we have there should be larger than 85. So to get x by itself, we're going to divide by that 38% as a decimal. And if we take 85 divided by 0.38, you get, ooh, not very nice. So this is about, this is one place that we're starting with decimals. It's okay if you end with decimals. Give me a good rounded answer to the nearest hundredth. So hundredth place is 2 decimals. So we're going to have 223 and 6/8 looks next door. That 4 says we're not halfway up to 9 yet, so we're going to keep the 8.68, about that. And if you took 223.68 times 0.38, we should get very close to 85. All right, if we rounded that to the nearest hundredth, we would get 85. Okay. Let's look at some ratios. So this is a ratio or proportion. A to B is equal to C to D is the same thing as if you put those things in a fraction. The important things about your proportion is that A has to go with B and A also goes with C. So they have to be in the same positions in your proportion. B has to go with A, but it also has to line up with D. So your numerators are lining up, your fractions are lining up, your denominators are lining up. Okay, we'll look at some examples of what that looks like. So 2 numbers are in the ratio 4 to 5. One number is 80 greater than the other number. Find the numbers. So if you're in the ratio 4 to 5 and one is 80 greater than the other number, that's the big one. That should be the big one here. Line up. Okay, so I know my ratio is 4 to 5. That needs to be equal to one number is 80 greater than the other number. So we're going to make the other number x. One number is 80 greater than that. Okay, the bigger one goes with the bigger one here. So this is x plus 80, and this is x. Right, so we don't know either of the numbers that we're looking for, but we do know that they have to relate to each other in this ratio of 4 to 5. Okay, this is not the only way that you can write this equation. Like I said, as long as you keep these things together, these things together, these things together, you can write this several different ways. So if your proportion looks a little different to start, that doesn't necessarily mean it's wrong, as long as your related parts are in your ratio or in the numerator, in the denominator. Okay. So if we go to solve this, we're going to multiply both sides by x plus 80. And multiply both sides by 5. Here, my x plus 80s cancel out, and I'm left with 5x. Here, my 5's cancel out, I'm left with 4 times x plus 80. Make sure you do put that in parentheses. We need to multiply that 4 by that whole thing that we're multiplying by. So simplifying here, we get 4x plus 4 times 8 is 32. So 4 times 80 is 320. Just get that extra factor of 10 in there. Equals 5x. So subtract 4x, subtract 4x. We get 320 equals x. There's more to this problem. So go back and look at 2 numbers. Oh, we only found 1 number. This is the other number. This is why defining your variable is helpful. One number is 80 greater than that number. So that means one number is 320. The other number is 80 more than 320. So our other number is 400. So 2 numbers, 400 and 320. Okay, they need to be in the ratio of 4 to 5. So that means if I take 320 and I divide it by 400, I should get that ratio of 4 to 5, 4/5. Okay. So that should still be equivalent to that ratio of 4 to 5. And let's try another one here. Suppose 50 grizzlies are tagged and released. On recapture, 75 grizzlies are caught, 20 of which are tagged. Estimate the number of grizzlies. So if we're looking at this, okay, kind of thinking of what are our situations here? So one of our ratios is going to be about the ones who are recaptured, and one of the ratios is going to be about the total amount of grizzlies. So we do need those things to relate to each other. So we need our caught versus total. Those are two of our categories. The other thing that we're looking at is tagged versus not tagged. So those are the things that need to relate within our ratio. So that's where when you're setting this up, your your proportion might not look the same as mine, but the pieces should still relate in the ratios themselves. Okay, so I'm gonna make my ratios the caught grizzlies versus the total grizzlies. So in the caught group, I'm gonna put my tagged grizzlies on, nope. I'm trying to find the total number of grizzlies, so I'm gonna make that my variable. Total grizzlies, always put it in the numerator if you have an option, has to compare to the total grizzlies the total grizzlies altogether compared to the total grizzlies tagged. Sorry. So the totals grizzlies tagged there are 50 grizzlies that were tagged total. Compared to the total, all the grizzlies that are out there should be equal to the ratio of those that are tagged that are caught. So 20 of the caught grizzlies are tagged and 75 total grizzlies were caught. Okay, so I changed this up here. It's not tagged versus not tagged. It's tagged versus total. That was my mistake. So the numerator here, this is the total caught, total in the wild. Okay, tagged that were caught, tagged that were in the wild. In the wild, caught. So they all relate in that horizontal or vertical. Again, yours could look different and that would be totally fine. So we could just solve this right off the bat and have some bigger numbers, or we could simplify before we solve. So 75 20ths, both of these are divisible by 5. So we can make this x over 50 equals 5 goes into 75 15 times, 5 goes into 24 times. So now our numbers are just a little smaller when we go to solve, which is totally fine. This is x divided by 50. So to undo dividing by 50, we can multiply by 50. So we get x is whatever this is. If it helps, write that over 1. Those 50s divide out. Okay. So we could multiply then simplify, or we could be smarter than that and simplify and multiply. 50 and 4 are both divisible by 2. So we have 25 times 15 divided by 2. So 25 times 15, that over 2. We get 187.5. Okay, can we have 187.5 grizzlies? No, that makes no sense. So we're going to round to the nearest grizzly, 188. Total. Okay. If you look at this, you want to see, does this make sense back in the situation? So if there were 50 tagged and released, does it make sense that there are 188 total? It should be more than 50, right? There are 75 caught, 20 of them were tagged, only a portion of the total population is tagged. So make sure you also look back and check to see if your answer makes sense within your situation. Okay, that is all for this video. Thank you so much for watching.